Okay, so Leetcode practice time. In this video, there are two goals. The first one is to see how to solve this problem, and then we are going to do some coding work. And the second goal is to see how to solve this problem properly by following the steps in the real interview. So let's get started. So remember, the first step is always to try to understand the problem. And if there is anything unclear, please bring out the questions to the interviewer. And also, at the same time, think about the edge cases. So let's say minimum window substring. So given two strings s and t, return the minimum window in s, which will contain all the characteristics in t. If there is no such window in s that covers all characteristics in t, return the empty string. So note that if there is such a window, it's guaranteed that there will always be only one unique minimum window in s. So the question, this is about to say that if there is a substring that satisfies the condition, there is only one minimum thing. You don't need to consider like multiple answers. So there will be either just one single answer or no answer. So example one, let's see this one. So the input is this, input is s is like this, t as abc, so the output is b, a, and c, which is a minimum substring that contains all the characters from abc. Alright, so the constraint says that the string cannot be empty, and s and t are consists of English letters. So we are pretty clear about the question, and there seems to be no very clear edge case. So let's think about the solution. So for this kind of string, the string question, there's a pretty common technique which is called sliding window. So sliding window is something like, suppose I use the dash, consecutive dash, to represent the string. So sliding window is part of the string. It's a substring, and it keeps moving. So for example, if it is static sliding window which has fixed length, it will keep moving forward until the end of the string. But it could also be some sliding window that change in size. So the common characteristics, the common thing, regardless whether it is static or non-static sliding window, is that it keeps moving the sliding window towards the end. There's no backtracking, and during the time you move, the condition you move the sliding window really depends on what type of the question is asking you to do. And also, during the time you move your sliding window, you will keep track of some statistics within the sliding window, which depends on what the question is, what question you're working on. So that's pretty much about sliding window. Let's see how we are going to use sliding window for this problem. So for this problem, it asks us to return the minimum substring that contains all the characters from t. So if it is AABC, we need to make sure that within the substring, A appears twice. So first of all, we are going to use sliding window to solve this problem, and the statistics we are going to keep track is we are going to keep track of the character and the corresponding frequency from string t. So for example, for example 1, we need to make sure that within the sliding window, so A has a frequency larger or equal to 1, B has a frequency larger or equal to 1, C has a frequency larger or equal to 1. And so we need to make sure that the character corresponding frequency of each character appeared in T should satisfy the condition before we can say that it is a substring that is valid. So let's see. So for example, Let's see if it is S, something like this, and T is ABC. So first of all, our sliding window will try to extend to the right side until we include at least 1A, 1B, and 1C. So here we hit 1A, 1B, and 1C. It's time for us to keep track of this current substring as a potential answer. And when we extend our right pointer to the right side and we get an answer, it's time for us to shrink the left side to see how many characters we could exclude from the current substring. So currently, suppose we shrink the left side, then we exclude 1A from it, which is not going to be valid. So that's the time we need to extend our right side again. So here we will extend to here, and now we have another A. So now it is longer. Actually, this candidate answer is longer, so we are not going to replace the current candidate answer we have because current candidate answer is shorter. So we keep shrinking the left side. Let's see. So we keep shrinking the left side until we exclude the C from it. So now that the sliding window is something like this, it's gonna be invalid again. Then we try to extend our right side until we hit the end. And now we have a candidate answer again, and it has a length as 7, which is still longer, but we can try to shrink the left side. So for example, when we shrink to this, we have a shorter answer, so we can totally replace the candidate answer as B, A, and C. So that's pretty much how we solve the problem. So the runtime is going to be linear to the input of the string, the length of the input string. Which is, suppose the length of S is n, so the runtime is going to be O of n. So that's pretty much about the common solution. Let's try to do some coding work on this approach. So first of all, we need to have a character to integer map. And then we need to keep a count to see how many characters we have already. So the count will be initialized as t.length, and during the time we move our sliding window, we will keep updating the car-free map, and at the same time we will keep a count which keeps track of how many characters left. We need to exclude how many characters left until we can get a valid substring that we can call it satisfy the condition. So let's see. So first of all, we will need to initialize a car-free map. So car C is to car array. Car free map dot put free map dot get or default C with 0 and +1. So until now we have initialized the car free map and the count. And now we are going to have the left pointer initialize as 0 and the right pointer initialize as 0 as well. And then we will need to have a candidate answer. Let's initialize it as a empty string. So if we initialize as the empty string, then we also need to keep track of the min length of the candidate. So let's see the min length of the candidate, or maybe we can have the min length of the candidate as 0, as integer dot max value. And also we have the mean start as let's say at 0. So let's get started to do some coding work on this sliding window approach. So well, right PTR is smaller than s.length. So well, right PTR is smaller than s.length. So if car free map dot contains so let's see, car c is equal to s dot car at right PTR. Let's see, call it c right. This is the current character we are pointing to at the right pointer. So the car free map. So the car free map if the car free map contains key the c right, then it's time for us to update the car free map. So car free map dot put c right dot car free map dot get c right and -1. So if car free map dot get c right, if it is larger or equal to a 0, then we are going to minus the count. So this part is saying if it is a character that exists in T, you just decrease the frequency of the corresponding character in our car free map, because it says we have already encountered the character from T, so we need one last of the corresponding character to make it a valid answer. So this if branch is saying that if currently the corresponding car free map is smaller than 0, then actually we have within this current substring we have more of the corresponding character we need, more of the corresponding character we need to make it a valid substring we are looking for. Yep. So in this one we will say okay, well, so if we have already encountered a valid answer, then the count should be 0. So it would be, well, count is equal to 0. Then we can try to shrink our left side. So what we could do is we could say so the length int the length is currently equal to right PTR minus the right PTR minus the left PTR and +1. So if length is smaller than the min length, you're going to have the min length set as length, and also we have the min start set as the left pointer. And if let's say we have this car c left as equal to s.car at left ptr. So this is the current left pointer. This is the character pointed by the left pointer currently. So if car free map dot contains key the c left, then we are going to say, alright, so car free map dot put c left with car free map dot get c left plus 1. Alright, so if the car free map dot get c left is larger than 0, that means we need at least one of the corresponding character to make it a valid string. Then it's time for us to plus the count. So when we plus the count, it means that for example, for this case, when first we have the string like this. So when we try to exclude this a, then it is going to make the current substring invalid for the condition we are looking for. So that's just an example. So, and then every time we are going to plus the left PTR, and also at the end we are going to plus the right PTR as well. And finally, if the min length is equal to integer dot max value, then we are going to return. So if it is invalid, then we are going to return empty string. So otherwise, we are going to return string dot substring from the beginning index, which is min start, to the end index, which is min start plus the min length. So after you're done with coding, it's not finished. You still need to do some testing. So if it's a not runnable platform, you need to explain how this piece of it is going to work by going through an example. At the same time, do some sanity check on the logic of it. And if it is runnable, I think you can just make use of the console to help you detect the bug. So let's try to explain how this piece of code is going to work. So first of all, we have S as this and T as ABC. Car free map is empty at the very beginning. Count is equal to 3, and we update the car free map as A1, B1, and C1. So we have the left and right pointer initialized. Min length initialized at the max value of the integer. Min start as 0. So while the right pointer is smaller than the s dot length, then we are going to try to get the character pointed by the right PTR. And then if the car free map has a corresponding character, then it means we need to update the frequency of the corresponding character in our car free map, because we need we may need just one less of the corresponding character to make it a valid answer. So we put this -1. So this one says if it is larger than 0, then it means larger or equal to 0, then it means we just need one less of the corresponding character. Otherwise, we have more of the corresponding character in the current substring than what we are looking for to make it a valid answer. So let's take a look at this example. I think until now we are good. So S is equal to this, and T is equal to ABC, and car free map. Let's say this is and this is L, this is R, and we have the min length, and we have min start. This is max, this is 0, and we have the car free map as something equal to A1, B1, and C1. Yeah, so at this moment, uh, we are going to try to we are going to say, okay, count. Okay, so count is equal to 3. So we say that count is currently equal to 3, and since A exists in this car-free map, we are going to update as 0, and it is the corresponding frequency is equal to 0, so we are going to minus the count. Now it's 2, and the count is now equal to 0, so this while loop is now reached. So we try to move our right answer. It's not the right pointer, and it's not something contained in car-free map, so we are going to skip it. Similar here, and when we encounter this B, it's another thing we need. So we update the frequency of B and also update the count as 1. And then we keep moving until we hit the C. Then we are going to decrease the frequency of C and decrease the count as 0. So when this is 0, then we are trying to move our right point. First of all, we need to record the answer. So right minus left plus 1 is 0, 1, 2, 3, 4, 5. 5 minus 0 plus, so now the min length is 6 and min start is 0. And then C left is equal to, so current left pointer pointing to A, so we are going to put A1 here. And the car-free map.get C left is larger than 0, so we are going to plus the count as 1. So that's the end of this while loop. So I think by going so far, everything works well. Yeah, I would say if we just keep moving, we should finally find the answer. I think overall, it seems to be good. It seems to be solid code. Let's give it a try. So right PTR is smaller than. Okay, so there is some typo here. Alright, so things seems to work. Let's give it a submission. Yeah, so I submitted a couple times before, several days before. It didn't work, and I spent some time to do some debugging, but glad we have the right version first time for today. So that's it for this coding question. And remember, after you run through the sample example to explain how this piece of code is gonna work and do some sanity check, it's time for you to set up some different test cases to increase the test coverage. So I would say for increasing the test coverage, definitely something like example 1, and also think about some example that doesn't have any answer, which is like we are going to return empty string. Yeah, so that's it for this coding puzzle. If you have any question about the solution or about anything, please leave some comments below. If you find this video helpful, please give me a thumb up and help subscribe to this channel, and I'll see you next time. Thanks for watching.